text mining, and you may want to ask the question, why do we need to do text mining? Text mining was not popular some 20 years ago, and I think it's an emerging thing which is just coming up now in the last 10, 15 years. It has been data mining and a few other things like that, data warehousing and what have you. But I can tell you that text mining is more or less like taking the lead now in the world of data science. So it is also important for you to know what is text mining and to have a feel about how to go about analyzing text. And I think one of the major reasons why this is becoming prevalent now is because of the advent of the proliferation of social media. Find out that on social media, people write a number of unstructured texts. They pass comments, they like other people's comments, and they also on Twitter, for example, they retweet and do so many things like that. On Facebook, you put your comments, and on other platforms where people put their comments. So all these comments are referred to as the user-generated comments. So which is quite enormous. Which is quite enormous, and most times, not even most times, all of the time, difficult for people to analyze, to make sense out of those comments. You find out that when you get to a particular platform where a product, for example, let us move where a product is being advertised and people are expected to pass their comments and things like that, or maybe a particular event and people are commenting, you see comments running into thousands. So how do you think it will be possible or very easy for whoever is the author of that post to begin to make sense of those comments? They may just be able to go through, peruse some few of them, maybe that are leading, and then see what people are saying. So, but then to save them from all this, to save time and to save them from unnecessary stress, people have come up with what is referred to as text mining, and that's what we're going to do tonight. So the first thing here, it's we want to see some important definitions in text mining. We want to see some relevant text analysis, the analysis that can be performed. What are those types of analysis that we need to perform in text analysis? Then we want to see installation and loading of relevant text related libraries. Libraries within R are packages that have been written by some people to assist us to do a few things that we don't have to repeat. So all we just need to do is just bring, just pull down the packages and then reuse them in our procedures for analysis. So there are some that have been dedicated for text analysis, for text mining, which we are going to begin to see. Now we're going to import data set as well into our R tonight. It's a given data set that I used for a book chapter I submitted last year, which I'm still expecting it to be out soon. So that's that data set I just downloaded online to explain the procedure of this text mining in that book chapter. So that's the exact Twitter downloads or Twitter data sets that I used for that analysis. So it's the same thing we're going to use for start working with from tonight, and then we'll finalize with it next week. So we're also going to see some pre-processing of the text. So we'll start that today, though we may not be able to finish because of the limited time. So now, procedure for document indexing. There are about 4 or 5 procedures which text will normally go through. After the download of the data set, or let me say after the download of or harvesting of a given data set you want to use, the next thing that the machine will do for you is to do tokenization. And then you can present your data in different forms. Your choice. But majorly we are going to see what is tokenization. Tokenization is the process of turning data into meaningful piece of strings. We all know what strings are. So tokenization will break your words, will break the corpus into words, into tokens. Yes, let me use that word. That will break, your text, the bundles of text that you have imported into meaningful pieces of strings that are meaningful, that are readable. So, and then filtration is a text mining technique as well, which focuses on identifying the extraction of entities and attributes. What are entities and attributes? Entities and attributes are more or less like fields. Like when you want to document the cases of patients in the hospital. We have so many patients, and then you have so many patients, and then you have their records. Now, in terms of, okay, you have their names, you have their addresses, you have their telephone number, age, and also all those things are referred to as attributes. So it's filtration in itself is a text mining technique focusing on identifying extraction of attributes and their relationship from semi-structured or unstructured text. Like I said, unstructured text are text like comments that we generate on social media because they're not structured. They're not in a given structure. You come in there, you put in your 2 lines, and you go away. Another person will come in there and just put 1 word and will go away. Another person will come in there and then write an epistle and go away. So there's no structure, for such tests. So that is what it does. And then stemming and lemmatization, they are twin brothers. They are more or less related in a way. So it is the stemming in itself is a process of reducing inflected or sometimes derived words. So they are word stem, paste or root form. What that is saying is you have a long name, like the word stemming is a big name. So stemming will prune it down into the root word, which is stem. Just like we have in stem, you can also have stemming. You can also have, what other things can you generate from stemming or something like that? Or let's say innovation, the word innovation, for example. You can have something like innovation, innovative, innovating, innovativeness. So all those words, if you want to catch them in your search, for example, you just stem them, you bring them, you prune them to their root. And then the root of those words is referred to as words. Let me allow you to speak. I want contribution to understand all that I've been saying. So I'll move to your microphone and speak. I use the word innovativeness. When you stem innovativeness, innovation, innovating, and every related word around that word, when you prune it down, which word can you get that can cover all these words? So that is referred to as stemming. So what is the root word for those words?
Innovate.
Thank you. That's a very good one. Innovate, Abby. You find out that if you use the word innovate, it will have the word innovativeness will not be when you write down innovate, use word in or innovate, VAT, stopping at T. So that way it will cover innovativeness, innovation, innovating, and other words, and others. So that is referred to as stemming. Is a form of stemming. But you agree with me that at the end of the day, that word, it's not a dictionary word. And that is why, rather than calling it Stemi, we call it lemmatization. Because if you look at the difference of lemmatization here, it says that the difference in that step, the difference is that stem might not be an actual word, whereas lemma is an actual language word. So, oh, sorry, that's Stemi. That's STEM. That's Stemi. The word, the innovat, innovate is Stemi. So, but lemmatization is the real word. So that is that. So this is also a plus for you when you are doing your search in your Google. Most people do not know that searching for relevant documents is more than just typing any word. There are some advanced way of searching for documents, and one of it is what we have learned tonight. So if you are searching for any, you want to search for any material published that has the word innovation, innovativeness, innovating, and all of that, you cannot get it unless you stem that word innovation or whatever into its root word, which is what we have learned tonight. The same thing is, can you give me a word as well again, which you can prune down that way? Can you raise a word? I want everyone to participate. Can you think of a word that you can stem down?
Inoculation.
Inoculation, that's a very good one. Inoculation. Then another thing along that inoculation is inoculate. I don't know if there's anything like inoculant, things like that. So then when you now step into the root word, what do you have?
Inoculate.
Yes, you won't say inoculate, inocul,
Okay.
And ending with L, I think that can be performed. There are about four major analyses that can be performed with a text. The first one is descriptive analysis. Another one is content analysis. Another one is sentiment analysis and network analysis. If you are writing any research proposal, you will get to a point, any research proposal related to text mining, you will get to a point that you have to bring in your methodologies, asking you to state what methodology do you want to adopt to achieve your purpose. Carrying out descriptive analysis on it. We're going to be doing content analysis, sentiment analysis, and network analysis. So we're going to begin to see them expatiate more on them. Descriptive analysis is like our descriptive statistics, which is the term given to analysis of data that helps to describe the nature of your data or show or summarize your data in a meaningful way. Like we used to use the word mean to look at the mean that will give us the minimum and the maximum. Like we also used to say describe to describe that data. I said to describe the structure. Like we used to say that I want to look at the frequency, to look at the frequency counts. How many of those words appear where? So these are some of the few things about summary that also tell you the standard deviation and then the variance of your data set. So that is descriptive. Another one is content analysis. You want to go deeper into just having the word on the surface. So it's a research method used to identify patterns in record communication. It's a research method used to identify patterns in recorded communication. Maybe you just want to see maybe like discussion along the line of medical line. Even within the medical lines, there are some other words that will be related. And these are some of the things that the machine, or let me say R, will pull together. So the machine wants to do clustering, understandable way, cluster analysis. So it's the content analysis that would assist in getting the related words. So another one is sentiment analysis, and then you'll be able to do some more in-depth study of that particular of those words within the data sets. That's about the content analysis. So the sentiment analysis now used to determine whether a statement is positive, negative, or is sitting on the fence, or is neutral. I'm not too sure I'll be going out tomorrow. What would you say about that? Would you say that is positive, negative, or neutral?
Neutral.
I'm expecting response.
Neutral.
I'm not sure whether I'll be going out tomorrow.
I think it looks neutral.
So how will you classify that? It's like as if it is neutral. But I will come back to that. Let me give you in fact, we have negative or neutral. Correct. Somebody else. You know, I was supposed to ask why you said, why do you say neutral? Because if you look at that word, we are going to kill. Kill is ash. That word kill alone is enough to say that this is negative word. So in a way, it's tilting to the left. But the other one, that first one I said was neutral. When I said that, I'm not too sure I'll be going out tomorrow because I'm neither here nor there. So, but then you don't have to bother yourself. I'm also going to I will open our tweets when we get there, and then we can also examine some of those words to see which of those words are. That is why the method we are going to begin to decide or it's neutral. So I move on. Then the last analysis here is network analysis. Network analysis is a sociology technique used to study relationship and community structures in social data. So it's like all the networks on Facebook, you are connected to a friend is connected to another friend, you are friends of friends and things like that. So social network analysis will bring relationship together in a graph that everybody can then see the connections at a glance. So there are packages that can handle all of these things, can also be done in R, but there are RapidMiner is also very good when it comes to a network analysis. RapidMiner can do that, but then it's not available for free. It's not available for free. It's not an open source. And a few other ones. But then it's also possible to achieve this in R. So let us see some useful natural language processing libraries, NLP. Installation of the packages must come first, as you can only load packages that have been installed. Like we have said in our previous classes that you have to install packages on your system. Any package whatsoever you need must be first installed on your computer, and then you load it up. You load it into the memory for you to use. So apparently, I'm sure if you have not done anything on text mining before, there will be a need for you to install your TM package, which you can easily install following that format, which you have done in the past. And then you can also install NLP as well. But then don't forget that you must be connected on the internet for you to be able to do successful installation of NLP. Maybe from your R, you want to be able to download tweets, you need to install Tweet R, not Twitter R, it's Tweet R. Then when you have all those ones installed, you can then begin to load them to the library. So now load relevant packages to R. You can load the TM is text mining. The string R is for your strings some commands are attached to string R. Anything that has to do with strings, you must ensure that you also load that. Then the XYUZ is for sentiment analysis, which also use, and it's for sentiment analysis. And then the word cloud as well is to grant you the word cloud is for you to say graphical representation of your words, of the words you have analyzed. And then our color brewer has to do with colors in your graphing, in your plots, you know. That can assist you to bring in some colors in your graphs when maybe during your clusters, you want a particular cluster to be blue, you want another one to be red, you want another one to be green. It is this R color brewer that will assist you to do that. And then the GG plot is for your plots, different types of plots, box plots, line graph, and what have you. Let us now go to install, familiarize us here now. If you look at this very closely, the first one here, top left, is your text, which has the main tweets. This is tweet messages. The second entity here, or the second field here, is called favorited. It's asking question whether favorited has to do with, do they like that statement or not? If it is favored, it will be true. If it's not favored, it will be false. So another one is followed by that. I can't see that clearly here, and so many other parameters like that. We also have the location. We have so many other things along that line. So, but then we're going to see it more clearly when we open the CSV file itself. It's already in the CSV. But you now find out at the end of the day, all other parameters, we do not need them for this our analysis. We only need the one in this column, in the text column. We only need to harvest all these texts. We want to bring them together in a corpus. We want to match them together, paste them together, harvest them together. So that, and then to neglect all other entities, all other attributes, all other fields in the data set. So let's go down. How do we bring data sets? This data set is your system. I also want to do it from your hand. This is what we have been doing. I'm sure by now you must have studied on your folder. In my own case here, I've studied in a place called analysis. So I'm going to check, go to my R now. And check my directory. So now that this is successfully loaded, we want to, I will first of all check to ensure that I am in the correct working directory. You can see now that it's not in the working directory, so I'm going to take it to my working directory where I have my climate document loaded. So that is an analysis. I'm going to open that again to confirm that it's, sorry. So I'm now in my analysis directory, which is fine. So all I need to do now is to put my climate.scsv that I want to bring into this document. So I prefer to call it the word text. I want to put it in a container called text, like an object. That's just my choice. And I will now say CSV read don't forget to put a double quote and then your what do we call it, name of the file, climate don't know why my system is doing slow .csv. And then I always like to put some other parameters. You need to instruct the system about the pattern, about the pattern separator. So the separator, it's comma, because it's a comma separated file. And then your string as header, because since we have header equal to true. Okay, header is true. So, but then even if you just put without all these additional parameters, it will assume this is what you are stating. It will still open your files. For me, I always like to put all of this. So I will just, that's why I did not include it in the one I uploaded to us. So it will assume it as fine. So that should save my document in text. You can see now that there's no error that is generated. So my document is in text. Let me just call it up to see what we have. I think I've not restarted my system for a long time. So this is it here. This is it here. But what I just want to do now is to view it rather than all these things matched together that I cannot see the difference. So let us view it. Let us view the text. I want to view it. View text. So that will give us what we have. You can see the view is giving us the structure of the data set, which is about the text here, the favorited here, favorized count here, in terms of how many are retweeted, I mean, the likes, how many likes. Then the date tab is also there. Truncated, I don't know what that means. Location, you will see location and a few other things that were captured on Twitter as provided by the Twitter API. But the discussion about that is not today, and it's not out. This data set was harvested. It's not today. So this is it here, and all of that. But what we need here, what we just want to extract is just the text column here. We just only need to extract the text column here, just the text column alone. So now the name of our object now that has been imported into R is called text. So, and I have taught you how to reference a particular entity, a particular field from a given data set. So how do you go about that? So I'll just say text $sign what again? Once you press that $sign, you will see all other attributes of that particular data set. Here you can see X, just like we have in our view. You can see text, just like we have in the view. You can see favorite type. You can see favorite count, reply sign, but we don't need all of this. What we need is just the text. We only need to select this one alone. We only need to select the text alone. You can see it has numbered it for us, but that's what we want to do. I just wanted you to see it so that by the time we use it again in the next command, it will not be straight to you. Then you can also play around this to see what is the dimension of the text, theme of text, to know how many documents or how many tweets were harvested, and how many variables does it have in terms of how many entities, how many attributes, how many fields does it have. So you can see 5,000 tweets were actually harvested with 17 variables. So you can also do a few things with it from there. So we have successfully done this. Then we have also built the data set. So what we now need to do now is to extract the text field to another object. We want to extract the text field to another object. So there is what we call paste. Paste is the function that will do that for us. Paste is a function that will do that for us. So it's going to collapse. It's going to collapse the text and paste it in a container called climate text. Into a container called climate text. So that's what we're going to do now. It's just my choice for climate. It can be anything. But what is most important for us is the paste. Paste. And what do you want to paste? What is that thing you want to paste? You want to paste your text, and then that's what you have. This is already stalled. It's already collapsed in your. But if you like as well, you can like I've done it here as well. You can put the word collapse is equal to dash dash. You know, like I've done there. Is equal to double quote, or what do you call it? So that's what you have. So you can then view this as well to see what you have within that. It's going to give you that this is just in a single column, in a single dimension. You can see it's taking time. Why is it taking time? Because it's processing a number of words. So that's why your computer must be a powerful one to be able to run large text on your computer, to be able to even perform some other operations beyond just this text, whatever. We are going to be about, it's going to get to a time that is going to be transposing your text, you know, transposing the documents to count the number of words. So if you are not using a very robust system, you may have problem. And it will even get to a time that your standalone system will not be able to handle your procedures in your heart. And that is why we call it big data. When you are processing big data, there may be a need for you to use the cloud to execute your work, to look for a bigger processing space to be able to do your work successfully. So if you view that climate text, you can see it here. It's going to give us that it's just in one single location. Can you see? Those are the text alone already harvested. Text alone already harvested and it's stored there. You can see that every other thing apart from the text has been removed from here. Has been removed from here. So this is really to collapse text in a document. So you can see that all of these things, they are not tidy, but the tidiness in terms of rearranging characters and all of that, they have will be the next thing that should be removed, because at the end of the day, you don't, all those things, they don't really add color to your text. They don't add any meaning to your text. So today, this is where we're going to stop. And then next week, we're going to finalize on the text mining. So today we have been able to, let me quickly recap. We have been able to see some important definitions about in the neighborhood of text mining. And then we have seen some relevant text analysis, which is, and I mean, one of those terms are tokenization. We have also talked about filtration, stemming, and lemmatization. And then I've given us an example, a ready-made example, which you can use, also begin to use even in our Google search for documents, in terms of, you know, pruning our words into stems. Then the following are some of the text-related analysis, descriptive analysis. We also talked about content analysis, sentiment analysis, and network analysis. Then I also told us that sentiment analysis is also called opinion mining. People want to mine opinion. We want to know the opinion of people, what people are saying about Trump, what people are saying about Buhari, what people are saying about who is the president of anywhere now. or even your state government. The governor of your state, you want to know what people are saying about it. So you can even apparently search his handle to even know what is happening to his handle as well, and then analyze every word within his handle as well. It can be done. Facebook can also be harvested to see the thoughts and the minds of people. So them is text TM, which is an abbreviation of text mining. Another one is string R. Another one is NLP, natural language processing. So all of these has to be there before you can call them. You can use related commands that emanated from them. So, and a few others. The word cloud is a graphical user interface or graphical representation of multiple words. That we'll see that word later. So we have dealt with this data set tonight, and we are only interested in the text aspect of it, which we have extracted after calling it up in this environment, and then we extracted it in and pasted it in climate text. So that is where we're ending. The data cleaning and all other analysis that we have to do will be done next week. So thank you for coming again tonight. Can I have you talk to me in case you have one or two questions? Like I told you, your assignment will be attended to tomorrow or day after, and then you have your feedback. So after the feedback, if you have challenges, we'll look for a time to also fix it together as well.
All right, sir.
Importing the data by yourself and do a few things with it. They ensure that you're able to extract one single location from it, and then you can also do a few things. At the same time, try as much as possible to experiment with lemmatization and stemming while you do your Google Scholar search to see the benefits that, oh, that's fine, so I can even do some more. So at least that will be part of what you have gained in this class. Thank you. If there are no other things, if there's any question, can we raise it now? Or if you have any suggestion, can we hear from you? Or you want to give some contributions? Glad to have that. Or you just want to say hi? Please feel free. Dr. Shuleke, you came late.
Hello, sir. Hello, sir.
Yeah, yes, sir.
I just want to, yes, sir. In case I want to use, let's say I'm interested in running an analysis, and I don't know the type of package that I would need, but I know, say for instance, I'm running a program.
Oh, okay.
Let's
Sorry about
say
that.
on econometrics, right? And
okay.
How do I source for the packages? I know the topic, and then I want to run analysis. Let's say on a special topic. Let's say, for instance, in my discipline, let's say econometrics now. And how do I start to source for the package? Is it, I don't know, how, is there a special way of searching for packages, different packages?
Okay.
No,
there's nothing you want to do in econometrics that the base package will not handle for you. Because in econometrics, what you just want to do is to write a kind of a model to look at relationship of among variables within your covariates and your independent variables. Your dependent and your independent, we need any special package for that. Within R, you don't need any special package to handle that. I think what you just need to do is, once you know what you want to do, once you know the model you want to formulate it on paper, and then transfer it to her, and then leave the rest to her to do the calculations for you.
Okay, thank you. Thank you, sir.
And then you do it. All right, in the absence of none, thank you. Have a nice rest. It's another day next week. Cheers.